Thank you. It's my great pleasure to be here. I am very honored that I have a chance to speak to you here in Korea. I was first in Korea 40 years ago, 1972. And that symbol you see above me is a symbol of optimism, which is what I got by visiting here 40 years ago and other places like Taiwan. I went on to see with my own eyes progress, people being lifted out of poverty and becoming some of the wealthiest people on earth. That's what I got from my visit here earlier, a sense that anything was possible. And I wanted to explore the origins of that through technology. So we have to begin 200 years ago. That's what biologists did in the world. They collected things. They went around the world and looked at different kinds of butterflies or ferns, starfish, and they put them in their cabinets of curiosities. There was no theory to explain how these things were related or where they came from. 200 years later, about 150 years ago, actually, Darwin and Alfred Wallace invented the theory of evolution, and suddenly we had an explanation for how these things came about. The problem we have with technology is that we're pre-Darwin. We don't have a theory for technology. Our lives are filled with one thing after another. First it's GPS, and then it's laser discs, and then it's genetic engineering, and then it's nanotubes. It's just one invention after another without any kind of a theory of how they're related to each other or where they come from. It's even worse because we don't have a good definition of technology. This is a common definition, which is that it's all the recent stuff. But obviously, most of the technology in this room has been around for a very long time. We have concrete, electrical lights. These are old technology. So technology has to be more than just stuff that's recent. Or maybe it's just stuff that doesn't work yet. It's this kind of stuff that's in the process. So I'm going to suggest a different definition for technology. These are two different human-made artifacts, two different technology artifacts. The one on the left is a stone axe that's about 50,000 years old. And I think that most people here, if I gave you enough time, could probably make one of those. The one on the right, obviously we all recognize, is a very current tool. But nobody here, even if I gave you 100 years, could make that by themselves. In fact, all of us here, as smart as we all are, even all of us together probably would not be able to make one of those mice. That's because each one of those mice is composed of hundreds of parts and other technologies that are necessary to make it, from a printed circuit IC chip to an optical laser to electrical wires to a plastic cast. And each of those technologies themselves would require hundreds of thousands of other technologies to make. And so in a certain sense, that artifact is not a standalone device, it's a network, it's an ecosystem of other technologies. And if we stand back from, say, the computer, we realize that there are thousands and thousands of components and thousands of sub-technologies necessary. And if we stand back even further and look at all the technology in this room, we realize that there's a kind of codependent, interrelated network of all these technologies that are supporting each other. And if we stand back even further to look at all the technology on Earth and realize that they are necessary for each other in a kind of self-recursive loop. To make a saw, we might need a hammer. To make a hammer, we might need a saw. They're all required to support each other. That large ecosystem of all the things that we make and are supporting each other, I call the technium. That's the technology in the plural. That's the big thing. It's more than just the sum of the parts. It is something in its own right. The technium has behaviors that are greater than the parts. So the technium can be, in some ways, lifelike, even though your shoe may not be alive, even though a light bulb's not alive, but the system itself has certain behaviors, like any system. Any system that we have ever looked at in nature or in artificial worlds has certain behaviors. And I want to explore what those behaviors are of this technium. Those behaviors are like leanings. They are certain tendencies. There are certain biases. And so I would say that the technology wants something. Not conscious want, but want in the sense that it's biased to that direction. This is a picture of a robot at Willow Garage in Stanford. And the robot can move around. It has 9 eyes, it has arms, and it travels around the building to find a plug to recharge itself. It takes this plug out and puts it into the wall. I had the opportunity to stand between it and the wall one time, and I was preventing it from putting itself in and recharging it, and you could tell that it wanted electricity. It wanted that. It was not conscious, but that's what it was about. And we can say the same thing about a plant. A plant wants light. It's not conscious, but there is a programmed tendency towards light for it. And I'm talking about the technium having those same kinds of built-in biases. If you keep repeating it again and again, it will go in a certain direction. So, the bad news, in some senses, is that the technium has its own agenda, to some extent. The good news for us is that it's a positive agenda. It has a moral dimension. It's not neutral. I'm going to argue that technology is not neutral, that in fact, overall, it has a positive direction. So, what does technology want? And I'm going to answer this in a sidestep. I'm going to talk about one of the most important discoveries in the last century, and one of the amazing discoveries, and that was with the discovery of the DNA code by Watson and Crick, where we realized that the essence of life was not carbon, it was not water, it was not tissue, it was not energy, it was information. That actually life was an information processing. That actually evolution itself, for over 4 billion years, was actually a long process of information evolving. That's what was evolving over time. And of course, technology itself is also an information process. We take design, intelligence, research, data, and we produce new things. It's an information processing. It's a rearrangement of atoms with new information. And so in a certain sense, there's an equivalency. They're not exactly the same, but there is an overlap between the living and the made, between the born and the made, that in fact, they share the same thing, which is an information processing. So I'm viewing life as an information process, and I'm going to answer the question about what technology wants by saying, if we can answer what life wants, what evolution wants, we'll have a really good approximation. So the question is, what does evolution want? And I think what evolution wants over the long term is harder to answer, it's more controversial, but let me give you a couple examples. We can tell over 4 billion years that what evolution produces again and again is more diversity. There's more species alive now than 4 billion years ago. Now, evolution is not like a ladder where we're climbing up higher and higher and higher. It's not this trajectory, but we know that things are simple and now are more complex. So that's another example of what evolution wants, is it wants more complexity. This complexity is, again, not a ladder, but a radial outward expansion. All things are becoming more complex. We are not more evolved than the bacteria. Anything that's alive is the same evolution, but everything is becoming more complex. So there's other things that it's moving towards, specialization, things become more specialized, and evolvability is a key thing. The thing about life is that over time, it evolves itself to be more evolvable. Things speed up. Things have more ways to evolve. So I'm suggesting that the same thing is happening in technology. Here's some spark pictures from locomotives a century ago. They almost look like those butterfly collections in terms of their diversity. There's huge diversity of everything that we make. And we have specialization. That first stone hammer was very general. You used it for everything. Over time, we made more specialized hammers. We have metalworking hammers. We make a camera that's a general purpose camera, and then we make specialized versions of a camera. We make an infrared camera, an underwater camera, a high-speed camera. Then we make a high-speed underwater camera. Then we make a high-speed underwater infrared camera. We keep making more and more specialized versions. In fact, we can kind of arrange technological evolution almost the same way we can arrange it for a genealogical tree. In fact, I would go so far as to say that if we take the map of the 6 kingdoms of life, that we can add a 7th kingdom coming out of the primates, which is the technium. That its behavior as a system is basically an extension of the behavior of evolution. And this 7th kingdom is the technium. So what does a technium want? What does technology want? It wants the same thing. It's moving towards the same set of trends that evolution has been for 4 billion years. So that's what evolution wants. Now, so what? If that's true, so what? Well, here's some things about how the technium works. Every time we have a new invention, it brings us almost as many new problems as solutions. So we would say, well, that's just a wash. That's equalizes. It cancels out. It's neutral. But there's a difference. Remember I said that hammer? Well, once that hammer came about, the first hammer that the Neanderthal picked up, he or she could use it to build a house, or they could use it to kill someone. They suddenly had a decision, a choice that they never had before. And that's what technology brings. It brings us new problems. In fact, most new problems in the world today are made by technology in the past. Most problems in the future are going to be generated by technology that we're making today. That's the downside. We have more and more benefits. That's the positive side. But we also have new choices with every one of these that we never had before. And those new choices tip the balance slightly, very, very slightly, in the favor of the positive. And that slight positive, maybe it's only 1%, is the thing that makes progress. So even if we use technology to create only 1% more than we use to destroy, that 1% compounded over years is the definition of civilization. That is progress. So it doesn't have to be much better. It has to be only a little better. And that little better comes from the fact that we have new choices we never had before. That is the power of technology. That's what technology brings us. When we are working every day making new stuff, we sometimes wonder, is this just a consumerist agenda? Are we just feeding the capitalist machine? Are we just making stuff that people are going to throw away? Are we just doing stuff for money? Maybe. But in addition to that, we're also making new possibilities. Now, what about the bad stuff? As I said, there are problems. Most of the new things being made by technology are generating new problems. Well, if I have a bad idea, if I'm going to give you a bad idea right now, what's your response? Your response shouldn't be, you shouldn't say, Kevin, stop thinking. The proper response to a bad idea is not to stop thinking, it's a better idea. The same thing with bad technology. If there's a technology like an incandescent light, we decide, oh, this is actually not the best thing. It's not to have no lights, no technology. It's to have better technology. So the response to the problems created by technology is not less technology, it's better technology. Okay? That better technology will produce new problems. They will need to be remedied with further technology. what we're getting out of the whole thing is increasing choices and opportunities. And by the way, I've never seen a technology that could not be made greener. There's nothing inherently anti-green or anti-life about technology. We would expect the seventh kingdom to be part of life. So technology is not anti-life. It can always be made greener and more compatible with life. And so that's what we can do. I think of technology as sort of our children, that we're trying to find the right job for them. There are no bad children. We're just trying to find the right set of friends. And so we have technology like DDT, which was used, sprayed in the millions of tons on plantations and fields as a crop pesticide. It was an environmental disaster. But the same molecule, the same technology, moved and used and sprayed judiciously in subtropical homesteads, is the most effective malaria eradicator that we have, saving hundreds of millions of lives a year. The same technology given a different job, the right position. And that's what we're kind of involved in, is finding the right home for technologies. So what does technology want? It increases the choices, diversity, options, and possibilities, and freedoms in our life. That's what it gives us in the end. And I'll tell you why that's important. It's because everybody here was born with a unique set, a different face, different set of genes and environment, and a special set of talents. And we often require technology to help us express those talents. So imagine, so Mozart needed the technology of the harpsichord and the piano to express his genius. But imagine if Mozart had been born 1,000 years before anyone had invented the piano or the symphony. What a loss to the world we would have had, and his own loss, not being able to have those technologies of the symphony to express his genius. Or imagine if Van Gogh had been born 1,000 years before we had invented cheap oil paints and canvas. What a loss to him and the world of his genius. The same thing with Hitchcock or Lucas or anyone. If they'd been born before we invented the technologies of cinema, that means that today, somewhere in the world, there's a young boy or girl, a genius, a Shakespeare of their time, who is waiting for us to invent their technology. That's why we have a moral obligation to invent as many possibilities in the world, so that every child born would have an opportunity to express their genius. And in addition to the new technology, they also, of course, need access to the old technologies of running water, education, roads. And so we have an obligation to increase the amount of technology in the world so that everybody potentially could express their genius. I want to emphasize that this technology, this self-organizing information that's running through life and running through the technium, is really a cosmic force. It's bigger than ourselves. It began at the Big Bang, and it started to organize and increase the diversity and the specialization of even atoms themselves. The heavenly bodies were all increasing their specialization, complexity, evolvability over time. And so in a certain sense, that the origins of the technium and life go back to the Big Bang, and that when we're seeing the self-organization which goes through the cosmos, and then the bios, and now the technos and the technium, that when we make things, invent new things, when we bring things to market, we're not just doing this for money. We're actually participating in something bigger than ourselves. We're participating in this arc of increasing possibilities that has begun at the Big Bang and is going through the universe and is go beyond us into the future, that we can participate in something bigger than ourselves. We can increase possibilities not in a ladder climbing up to some apex, but in a kind of radical expansion outward in all directions. And that's what we get from technology. That's what technology wants. Thank you for your attention.